In this question, I ask you to evaluate the integral of cosine of ln of x dx. So let us try our best and use the method of integration by parts or any other method that think work for us to evaluate this integral. So take a look. If I take t to be ln of x, then dt becomes 1 over x dx. So dx is equal to x dt, but from the very first equation, x is equal to e to power t. So we can write everything in terms of t. So I'm rewriting this integral as the integral of cosine of t, and for dx, I'm using x dt, but x is equal to e to power t. So you end up with e to power t dt. Very good. So what should I do now? Right. I rewrite this integral in terms of t now. Can I use integration by parts? Well, let us try. In the method of integration by parts, the integral of u dv can be written as uv minus the integral of v du. So what's the choice for our u? What's the choice for our dv? Let's see. It doesn't matter, to be honest, which one is u, which one is dv, because you see repetition here. So pay attention, please. If I take, for example, u to be cosine t and then dv equals to e to t dt, my du is equal to negative sine t, and my v is the integral of et dt. So v is just e to power t. Perfect. So let us apply the method of integration by parts and try to simplify this guy as much as we can. This integral can be written as uv. I'll write this here, then try to simplify. So uv, which is cosine t, times e to power t minus the integral of v du, which is e to power t. And let me just plus sine t and dt. Okay, here we go. Okay, so what's happening here? I still have e to power t sine t inside my integral. So if I write this guy this way, it shows repetition. It keeps repeating itself. What's the meaning of that? It means that if I apply integration by parts for the second time, I should see the same repetition here. Okay. So repeat integration by parts until you can simplify this further. Integration by parts for the second time. Again, so take u to be sine t, and then let us take dv to be e to power t dt. So your du becomes cosine t dt, and v again is equal to e to power t. So this integral is equal to, so I'm going to copy this guy down, cosine t, e to power t, cosine t, e to power t, plus I'm going to open up a bracket, uv, which is sine t, e to power t, minus the integral of v du. Let me move this a little bit down here, minus the integral of v du, but v is e to power t, and du is cosine t dt. Now let me close up the bracket. So I took this guy and applied integration by parts again for it. Use the same color. And I got this one. Now what? Okay, take a look. This integral can be written as, so my original integral, what was it? It was the integral of cosine t e to power t, all right? This was the integral that I had. Let me copy this guy down here for you. This in turn is written as cosine t e to power t plus sine t e to power t. And then I again got another integral minus the integral of cosine t e to t dt. Hey, it is repeating itself. What should I do now? It's a very simple idea. From algebra, if you call this guy, this integral, let us call it I, you have I on the other side as well. Okay, it means that I is equal to cosine t e to power t plus sine t e to power t minus I. So if I bring I to the other side, I get 2I equals to cosine t e to power t plus sine t e to power t. What's the meaning of that? Well, from algebra, I is equal to a half. You can factor out e to power t and write down cosine t plus sine t. Hey, we found the integral. I is equal to the integral of cosine t e to t dt, which is equal to a half e to t times cosine t plus sine t. But wait, my original integral was in a different variable, right? My original integral was in x. So I need to rewrite everything in terms of x now. What was the substitution that they used at the beginning? Let us go back and take a look. This is what I had. I'm going to take this guy and copy it down here. My t was ln of x. So wherever I see t, I'm going to write down ln of x. And e to power t is equal to x itself. So this integral, the integral of cosine t e to power t dt, which was original. Let me write it down in original format to avoid any confusion. So the integral of cosine of ln of x e to power t was x, and here you had your dt, right? It was equal to dx. Can be written as a half e to power t, which is just x, and cosine of ln of x plus sine of ln of x. Ooh, a lot of work, right? Don't forget to add the constant of integration, and this is it. This is one of the challenging questions when it comes to taking the integrals. The integral repeats itself when you apply the method of integration by parts. So we have to use algebra and try to simplify as much as we can. So take a look at the very top part. On the top part, we had the integral of cosine of ln of x dx. We made some adjustments to make it a little bit nicer. We took t to be ln of x, and x is e to power t. So when you're taking the derivative of t, it is 1 over x dx, or dx is x dt, or dx is e to power t dt. That's how you end up with e to power t dt because of this. And for this integral, we applied integration by parts. But when we applied integration by parts, the integral of e to power t cosine t appeared. So we applied integration by parts for the second time. But when we did that, we got the original integral back at the end. We ended up with the integral of cosine t e to power t on the left-hand side and its opposite on the right-hand side. We used algebra. We called this integral a quantity like I, m, anything that you like. Then bring negative I to the other side. You get 2i equals to cosine t e to t plus sine t e to t. When you divide everything by 2, I is equal to a half e to power t times cosine t plus sine t. And what was I originally? I was the integral of cosine t e to power t dt that you wrote down on the left-hand side. This is basically your I. So I, or this integral, in t is a half e to power t cosine t plus sine t, but our original integral was in x, so we needed to rewrite everything in terms of x. So we are going back to the original substitution that we used. Wherever we see t, we're going to use ln of x, and our e to power t dt is dx. So we just substitute everything back, and this is the integral of cosine of ln of x dx.